Good morning, good afternoon. I hope we are online, and it seems we are. So this KiCad live stream, design live stream, will be the third in a row for the active oscilloscope probe with the projected bandwidth of 2 GHz. This is not my design. I am redesigning the existing design by a much better designer than I am. I can tell you his name, but yeah, this is the repository, and I forget the name, but yeah, probably there is something. You can visit the link, the project hosting site, which is rolling on the bottom edge of the screen. And now I am looking for the original schematic. Last time we didn't finish the, I think, feedback network of the main high-speed op-amp plus the auxiliary op-amp isn't, the network of the auxiliary op-amp isn't finished as well. Our schematic looks like this, and I will stop talking about unimportant things, and I will start working on the schematic. So here is the original schematic. I will use the split screen mode as always. It's not optimal for my work, but I think it's the best way for you to see me on the right side as working on the schematic, and the original schematic is on the left half of the screen. So a short review. Last time we struggled to identify the capacitors, but we managed to do that. Now I can see that there are still some capacitors here near the output. I don't know why they are there. Probably some auxiliary. Yeah, I beg your pardon, I didn't do my homework. I didn't watch the last design stream that was, I don't know, published a week before Christmas, so 2 weeks ago or 3, I don't know, never mind. I think these 3 caps are for the VSO plus or VSO minus, but those 2 power entry networks are already created and edited, and I think successfully, so these caps can be removed like this. There is the CLL1K resistor here from CLL. To resistor and then to VEE, yes. There is not connected port connected with the CL. I have to check it. Yeah, we need the data sheet. Here is the link, and we are looking for the non-connected ports of the symbol or package. Number 9, 13, 16 are not connected. Do not connect. They say do not connect, and I will not. Okay, so in aux is the output of the auxiliary op-amp. Yeah, here are already decoupling capacitors for the power entries. So for the aux input, I will prepare these two caps. Not prepare, I will place them as they should be placed for decoupling the power distribution network, let's say, and here is the VCC, here is formally pointing upwards. VCC is pointing upwards and VEE is pointing downwards because it's a negative power entry input. And this composition looks the best. So we can move the op-amp closer to the buff. I can see that there is 47 picofarads feedback capacitor at the OPA 140. So I need to identify if I have 47 picofarads in my database, only 0805, which is too big. Let me open the bill of materials of the design. Here it is, and the affected, no, I don't want to comment, go away. I'll zoom in a little, and we are looking for the C2. C2 is no, C2, okay, is here. No, it's C22. C2 is here. It's a 47 pico rated with 50 volts, C0G or NP0 in 0402 package. So I have to create a new component for our usage. I can modify it, for instance, 33 or 36, 33 picofarad cap in 0402. This is it. Just by copying, because it holds it. Yeah, it contains the valid footprint. I just need to edit this. Okay. Yeah, there is such a attribute. Okay, so let's check this part number. I don't know what manufacturer it is. It seems it's a stocked Samsung. That's fine, and we can play a little with the part number because we are looking for 47 picofarads. This is it. More than 200,000 pieces. That's what we are looking for. And in the meantime, we will need 47 pico, 50 volts, 0402. We will need the JLC PCB code. One of the most, I think the Murata is the best candidate. So here we need a new part number and data sheet to be added here. Okay, 47 𝗶𝗶𝗃𝗃. That looks good. So, and it's a feedback capacitor in the feedback network of the op-amp. The loop is slightly larger than in the original design because they don't place the decoupling capacitor near the op-amp symbol. The decoupling capacitor are somewhere in the universe. I don't like this approach. The price of the not so looking schematic is definitely balanced with the clarity of the schematic. 5K6 R15. Let's check the footprint. I guess it's 0402 again. R15. Yes, 0402. So yeah, I have such a resistor, but it needs to be edited because since probably beginning of last year I started adding the JLC PCB codes because many of my customers won't order a JLC PCB, so I want to be prepared because the component sourcing is the most difficult part of hardware design to me. I always screw it up. So yeah, when the JLC PCB codes are present in the symbol, it means that there is not zero chance of a mistake, but minimized chance of mistake, and this is what I want. Yes. So the resistor leads from the output to the in aux, and there is a 100 picofarad C3 capacitor at the input of the at the in aux input C3. Let's check the package. C3 here 0402 100 pico at 50 volts. So let's check again my database. 100 picofarads should be there. Yes, it is here. I have to check the JLC PCB code. Not present, so I need to edit. 100 picofarads, no percentage, 0402. Samsung, this is our horse. Perfect. Let's place it here. Okay, what are the other inputs? Our bias are connected with all the aux bias, VS minus, VSO minus, and not connected with VEE. You can see how how bad this symbol is. There are no pin numbers, so you don't know what NC pin is mentioned here. There are 3 of them. I encourage you, always use pin numbers for at least ICs, always. Because, yeah. Okay, R bias 17K0. R16, I definitely don't have this value in my database. R16, 020, 0402, 17K. Yageo, okay, I can use this part number to save my time looking for the correct resistor. This one is definitely correct. Okay, so let's use it. And as again, I will adapt some 17K8. Am I right? 17K8, yes. $17K8, 1%. Yageo Mauser, as we saw, just PCB empty for now. Datasheet and the GLC PCB code. 17K8, 17.8K ohm. This is a working notation to eliminate some other components like, yeah. Okay, this Uniroyal looks good. Fine. So this resistor is to be connected from R bias to VEE. R bias to VEE. Okay. Aux bias and 𝗞𝗿. 𝗞𝗿 is to be connected with ground. But R bias is to be connected through the resistor to VEE. And the aux bias with VEE as well. So I'm going to modify the symbol to avoid crossing the lines and yeah, complex shapes of the network, of the signal network. Yes, it's much better. Yeah, this is what I want, exactly what I want. Okay, so let's check it. We have R bias through the 17K8 to VEE, and we have aux bias to VEE directly. VS minus minus, of course, VSO minus to VEE. There is a battery of decoupling capacitors. One of them at the VS1, the second one at, sorry, the second one at VSO minus, and the 10 nanofarads somewhere in between. Okay. Okay. So output of the op-amp is here. Here is another feedback from output 50K, 51K to negative input. So yeah, 51K 𝗵𝗁𝗀, R11. It's a lot of work. When one have to add each resistor separately, it's a lot of work. 𝗵𝗁𝗀. I can check, but I think I will not have this resistor. Oh, see, I have. Good message, even with GLC PCB code. Okay. That's called happiness. So what else? When I touched the output, there is 49.9 resistor with the R19 reference designator. R19 is 0402. 40. Yeah, I have it already, even with the correct code. Okay, but I will change it because I don't buy passives at Farnell anymore. Okay, this is our resistor. So datasheet is here and MOC, manufacturer's order code, is here and 1%. Let's make a quick check of the GLC PCB code because yes, that's our cap resistor. Okay, this resistor is correctly created. You can ask why I always close the symbol editor and open it again. The reason is that when I stream, I don't know why, but the switching of the windows doesn't work. So I can't switch between the KiCad windows. So I always have to close it because when there is a full screen window, I can't switch to the schematic editor back. So yeah, I don't know why, but it is what it is. 10K R12. Okay, I will definitely have in my database such a resistor. Yes, but with the Farnell code, I need to change it. This is 17K, so let's try to modify it for 10K. Let's see. 10K5, 10K7, 10K. This is our resistor. 7 million on stock. Okay. Resistor, but now the difficult part is coming. Why? The resistor trimmer. That's always issue, but we will see. R13 trimmer. Let's check what type it is and if it's available. Yeah, this is this burns. Single turn, sealed. I think I have similar, not PVG3, but a similar one. I think, not trimmer. One turn, 10K. This one, and this one is vertical. What? Yeah, I meant this one. I meant this one. I think these two, yeah, let's use the split screen. How to, I should open the, this is what I want. This is the original one, Burns, and this is the 𝗏𝘁𝗲. Oh, the Burns looks better. I think I will use, oh, the Burns is for the half of the price. Strange. The price doesn't matter. Yeah, don't get me wrong, but what's this? It's 10K, of course, but single turn Burns. Cermat, yes. Top slot, of course. The same wattage, the same tolerance, better temperature coefficient. I will go with it, with this one, but of course 1K. No, 1K. What's the value? I forgot. 1K, okay. 1K, okay. This one, 4,000 on stock, perfect price, and better performance than the original one. I don't need datasheet because it's already in here. Save as. For the trimmers and similar devices, I use the symbol name the same as manufacturer order code because I want to avoid like 1K, 1%, 1 turn, version 1 or Burns or yeah, some strange names. So I will keep the GLC PCB code for a while because I want to use the similar or the same manufacturer from the GLC PCB. A few parameters. 1K, 20%, 4mm. So I will add 20%, 20%. 4mm. And the GLC PCB code. Yeah. Oh, Burns, see? So we can use our Burns code on stock for half of the price. But 1K, 1K, one turn, 20%, 0.25 watt. This is it. To keep the same notation with the other ones. Perfect. And what's the orientation? We don't know. Does it depend? Well, does it matter? I wanted to say. Yeah, it depends. It depends because, of course, the direction drives the sense of rotation when you turn with the trimmer. So yeah, I'll use this. We have some comments. Hi Shiva. I don't know if my voice is a little bit breaking. Maybe I should dance, like breakdance. I don't know. I'm sorry for your problems with the sound. I don't have a way how to verify. Okay. 68 ohm R9. Zero 402. Miracle. So directly from the non-inverting input, 66.5 R8, definitely not in my database. $66.5 it was. I immediately 66.5K. Immediately forget the value. Yes, this 𝗬𝘰𝗀 looks good. And here, yes, this part number works as well. Do you know what I don't understand? Why the Mouser Electronics have almost 2 million of such a strange value? If it's 1K or 10K, I don't ask, I understand. But 66.5K, 2 million, that's like 1,000 rolls. or maybe more. Why? Oh. Who I am to ask? 𝗏𝗏𝘀𝗶𝗏. Yes. So now this register prepared from the last time, just a short check if we have the correct value. We do. And it goes somewhere here. Yes. Okay, this network is already created. Okay. Okay, so I can move it. Like here. Yes. But a little bit higher. Yes. Yes. That's one. Tip. Okay. As I said, I didn't do my homework. I don't know what tip spring-loaded thing we will use. The coaxial connector, I would like to use the edge SMA. This one. I don't know if it's still possible, if it's still available. Ooh, definitely not the Mauser. Okay, I don't know why, because I am putting there two part numbers. See? Aha, this is the long one. It is. Yes. I don't want to use it. The other one, I think I had the short one, the normal one. This is the reverse polarity. Be aware of this devil. Yeah, there is a SMA connector with reverse polarity. Don't even touch it. That's evil, pure evil. Go away, go away. Anyway. I have only angular ones and vertical one. The angular one have definitely the big advantage that it's like super universal. All manufacturers follow the same footprint. You can buy anywhere and it fits. Okay, so this one will be Molex. Let's check the 𝗬𝗲𝗃𝗃. I don't think they will have it. Yeah. We have to use something like this. The section is coaxial connectors RF, okay. Why I'm still looking for the part number at 𝗬𝗲𝗃𝗃? Because there was stated 6 GHz as a bandwidth, and I don't think it's an issue, but the original Molex one has the 18, and I want the same frequency range, frequency bandwidth. As I said, I don't think it's an issue, but package type plugin. I don't know what's plugin. This is the longer one, vertical one, vertical, vertical. Is it something like board side connector? Interface diameter. SMA. I'll go with this one. It's old good Amphenol. I don't think I can go wrong with it. And I probably checked it already, but I don't remember. Yeah, 0 on stock. Okay. Okay. Okay, so we can remove our task, SMA, power entry connector, power entry, barrel connector, Yeah, I think it's done. Ground pin connection. So we have to think about it for a while. I think last time I already checked these, and they use a nice spring-loaded tips. I don't know what manufacturer it is. Yeah, I think the original that's, I think it's in my, yes. This is Active Pro by 𝗏𝗏𝘀𝗶𝗃. This is our, yeah, the original designer used the ground tip near the, or ground connection near the spring-loaded tape on two sides. I think there is no photo of the final assembly, like with an enclosure. Spring-loaded tip. What about chassis ground? I don't know. I will expose a pad or a set of pads with the ground, just the ground. Spring-loaded. I'm shooting blind. Milmax, I think. I think I can follow the strategy as the James Wilson did or had, just a soldering pads. Oval. What's this? Oh, that's not. Yeah. 4.5 times 2.5. That can be our soldering pad. Yeah. And as Jitesh said, we can use like 4 of these. Okay, it's not solved, but there will be soldering pads, and I think I have some spring-loaded thing somewhere in the drawer, and if not, I can look for it. I think 𝗏𝗁 did something. I don't know how. Yeah, this is the company. Terminals, power to pin and socket connectors, manual, contacts. But it's not spring loaded, it's only contact. But I have some spring loaded. Between test points. Circular. I would like to find it. Spring-loaded pins, but these pins are like for test beds and similar things. I need a sharp pin with spring inside. But if they do spring-loaded pins at 𝗏𝗁, they can do the sharp pin thing as well. Let's visit their website. 𝗏𝗁, not this one. Okay. Probably it's not the receptacles and sockets, but I think, and pins, and I think I need something different. Yeah, they have only pins like for test pads and similar things. No, that's not what I want to use. Spring-loaded contact, McMaster Care, pogo pins, spring connection. Okay, we have a few. Harwin, TE, Amphenol. Okay, let's check it. McMaster Car, spring test probes. I would like, oh, spear tape. Cool, that's nice. How it works? How does it work? This one looks good. What's this? Spear tip. Spring test probes. 30-degree spear tip. 2.54 millimeter diameter between probe. Aha, minimal diameter between probes. 12 amps per detail. Okay, there is a change of the length. The price is crazy high, but doesn't matter. I thought it. They will not easy to buy. Okay. The 𝗏𝗏𝗀𝗺 car looks perfect, but probe pin obsolete. Who is obsolete? Omron. Oh, I've never seen something like this. Okay. Okay, industrial spring contacts. Okay. Nice. Who is your distributor? We can download the step file. Order. Document. Locations. Okay. 𝗏𝗏𝗀𝗃 car. 𝗏𝗏𝗀𝗃 car. 𝗏𝗏𝗀𝗃 car. 𝗏𝗏𝗀𝗃 car. Distributor. Distributors. Those are some fittings. I don't need fittings. I need my sharp pin. 𝗏𝗏𝗀𝗃 car, contact us. Chicago, Illinois. Maybe they say directly. They sell directly. Probably. I don't know. EBS. I think something normal like Farnell, DigiKey, Mauser, Arrow. Something like in the original design, on the top of the probe, like the probe will be shaped similarly, and here will be the spring-loaded pin. Okay, I will keep this question open, and probably I will send them an inquiry or a question of what is their who is their distributor. and we will see. For the tip looks very good, and for now I think it's enough to know that there will be a soldering pad. Now I want to do something unpleasant, which is using the same references as in the original design. Why? To don't mess with the universe. I spotted a mistake. These two capacitors are switched. Yes. C9. C6, R20, no, yes, R20. I should have done this before when I edited the schematic, but I didn't know I would need it at the end. But it's not such a big deal. Well, I will start with the decoupling caps for the VCC, which is C20. I'm going from the right to the left, C16 and C14. And the other ones are C15, C17, C21. There is one extra 10 nanofarads, but I don't know where to place it. As I said multiple times, don't use this. Never, never create a battery of decoupling capacitors without a connection to the real symbols. It's a mess and everybody will hate you. I will enter all the components I can identify, and the rest ones will be assigned using the annotation tool. Probably it will fill some empty spaces. Not some, all the empty spaces. R2, C1, R4, R3, C4, C5, not 6, R1, J1, J2, J5, R6, R9, R8, the trimmer is R13, R12, the feedback R11, and the capacitor C2. Yeah, these two will be C12, C4, C12, C13, and J3 is the SMA. The extra soldering pads will be assigned using the annotation tool. Okay, so let's annotate it. R5. Okay, so back. I forget these two. R15 is here and C3 is here. So now annotation, and it seems that they use, yeah, the same exposition strategy. Okay, so back again, I forget UPA. OPA is U2 and buff is U1. Again. Now it seems that we succeeded. Okay. Okay. So we are 70 minutes in the show. I will call the ERC checker. Okay. Okay. Pin not connected. U2 hidden pin. I think there is an issue with this. Symbol. NC. No internal connection, can be left floating. I would like to ground it because I don't think it's reasonable to keep yeah, now I understand. Okay, I will ground the pins. It means that I will make them visible, but how? I don't know, I'm just trying. And definitely I will make the NC pins visible here. And I will use the same strategy as the original design. So I will place the NC near each neighboring pin to be connected with. For instance, the NC near the CLH is here, so pin number 16 will be close to CLH. I don't know if it's possible. If it's possible, I hope so. 16 will be place 15. Aha, see, I tried to make it already. 16, no. 16, here will be 13. And the last one is pin number 9, which is close to VSO minus probably. What's the original design? Yeah, VSO minus. So VSO minus, okay, pin number 9. And this will be passive visible. Nice. Now CLL and C, okay. And CVSO minus, okay. And CLH to NC. No. Okay, can be. Can be. No metal part will be floating on the op-amp. That can cause some EMI issues. It means it can disrupt the performance of the amp. Okay, let's deal with the ERC. So ground needs the power flag. For instance, here. 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 No, here. Zero, zero. That's what we want. Okay. Let's check the original design. I can close this spreadsheet, quit anyway. This will be kept open. I can close this one, this one, this one, this one not, because I will going to send an email to 𝗏𝗏𝗀𝗃. This is the 4-layer stack up by 𝗏𝘁𝗃𝗃, which is this one with the substrate by 𝗲𝘀. Okay, couple specifications. Okay. I will use different stack up, but it will only affect this 50 ohm RF path. So out RF and SMA RF. All RF. Okay. Now I will create the net class for the 50 ohm single-ended. No numbers needed for now. I only want to assign the net class here. Okay, and here as well. Okay, so these two nets will be only the impedance controlled in the entire design. That looks good. And the original design again is here. And close this, and this tab. Okay. I'm checking the PCB size. Probably there are some measurements, outputs measurement, simulation, manufacturing. Probably I should, if I want, I should. Here is assembly, but no dimensions. Probe outline here. So we can import the I think we can import the XF or not. Let's see. No. This. Board outline. Yes. It's not in scale. It looks like 100. Oh, motherfucker. Okay, so here is the SO8, which is like 3 millimeters wide. 6, 9, 12, 15, 8, 21, 24, 27, 30, 35, let's say, 40, 50, let's say. If I used 100, it was like 250. So 25, let's say 25. Let's make a check. No, I can import the components already. Okay, and here is our SOC, and we can use a trick. Screenshot. This is rope. By importing graphics, rope, it's unknown. It's slightly bigger. Can be something like this. So it means that our shape is I don't know what can be the. Is it possible that there is no drawing with dimensions? I can import the. Okay, I can import the Gerbers. Yeah. To detected files, original, okay, original project, manufacturing, board, manufacturing, Gerbers, and here is our scale, which is 70 millimeters long. Okay. So again, I have to import our graphics. It was too small. Maybe 30, I don't know. Now we will do the math. When we use 30, it's 82.5, but the target is 70. So 70 over 82.5 times 30 is 25.5. So 25 was not so long. Was not so far from the reality. Maybe it's connected with the ratio between imperial and metric system. That's more than mysterious. And we will change the ratio of this again. The size on the image is 86, but we need 70. 70 over 86 is 0.814. Okay, we can set the opacity. Nice. I don't say that I will copy the probe one by one. but this can definitely help. Okay, I think for now we are 90 minutes in the show. I think we did good job today. Frankly, I didn't expect that this will take so long, but it is what it is. And next time we will place all components and hopefully finish the PCB layout. So thank you for watching. Thank you for being here. I hope you enjoyed the show. If not, next time it will be better. See you next week. Bye. I forgot something. If you let's say like what I do, and if you want to support me, if you want to learn something, if you want to, I don't know, be a better KiCad user, I created 2 online courses at 𝗬𝗲𝗺𝗀.com. KiCad for Makers is the more advanced one, and KiCad for Beginners is the basic one. Essentials, schematic capture, footprint creation, symbol creation, import graphics, PCB layout, library management, manufacturing data export, everything is here, essentials, but you can live with it and start with the skills gained from this course. It will take you, I don't know, 10 hours to finish the entire thing. The course is 2.5 hours or 3 hours max. And the KiCad for Makers is more advanced. There is 2 dual-core MCU, M2 connector for note cards, 2 power supplies, a bunch of other things, USB Type-C connectors, everything is there. Again, I shrinked the course to 3.5 hours, but it will take much longer to finish the board. If you would like to follow the guide, I guess 20 hours. Maybe more. The raw material I recorded was 18 plus hours. So if you are not so fast, it can take like 25-30 hours. I don't know. So if you want, I recommend. If you want to start with KiCad, I recommend KiCad for Beginners. If you want to improve your skills, I recommend considering taking the KiCad for Makers course. You won't regret. Again, thank you for being here. Thank you for watching, and see you next week. Bye.